of my contribution to the book was, is Cubism a possible solution to the conceptual problems of quantum mechanics? But what I actually did is a comparison between two interpretations, Cubism and Convivial Solipsism, which is an interpretation I developed after Bernard d'Espagna, nearly at the same time than Cubism, and that's what I'm going to present here. So what I'm going to do is a presentation of Cubism and the main criticism that it's possible to address to it, then a presentation of Convivial Solipsism and the common point that they have. They have many common points. That's the reason why it's interesting to compare them. But also the differences, and there are many important differences that I will outline at the end of the talk. Cubism and Convivial Solipsism are two interpretations that have been developed for giving a correct interpretation of the quantum formalism. And I insist on saying that of the quantum formalism in a non-modified version. That's, even if the talk this morning showed that there is no unique orthodox interpretation, Cubism and Convivial Solipsism are inside what Matt Leffer called neo-Copenhagish interpretation. That means interpretation that doesn't need to modify the quantum formalism differently of, for example, DBB theory or GRW theory. So we stick to the usual formalism. And of course, one of the goals is to solve the measurement problem. There have, as I said, many common points, but some very important differences. A bit of history. The name Cubism appeared in 2009 in an archive article, which has been published a little bit later in 2013. And Cubism, which should stay unanalyzed, that you don't have to try to understand what Cubism means now, but at the time it was the version of quantum Bayesianism. That's no more like that. But at the very beginning it was the quantum Bayesianism, and it was initially developed by Caves, Fuchs, and Schack, starting in 2002. Now Schack has some discrepancy with Cubism, but David Mermin joined the team and is an ardent supporter now of Cubism. Convivial Solipsism, I've started to develop that around 2000, following a remark from Bernard d'Espagna in his 1971 book, Conceptual Foundations of Quantum Mechanics. I'm going to explain that later. So let's start by Cubism. Cubism is a theory on interpretation for which the central subject of science is not the external world, but it's the primitive concept of experience, which is, for cubists, the way in which the world impinges on any agent and how the agent impinges on the world. And they adopt the subjective interpretation of probability. Probabilities doesn't represent something that is linked to the system, but probabilities represent the degrees of belief of the agent. And that's very important also, it is for them a single, as they say, a single user theory. That means that probability assignments express the beliefs of the agent who makes them and refer to the same agent's expectations for our subsequent experiences. That's a quotation from Fuchs, Mermin, and Schack in 2014. The entities of the formalisms, the wave function, the observables, the Hamiltonians, the probabilities, are not objective and attached to an external reality. They are subjective in nature and have no absolute value, but are relative to a particular agent. And the important point also to notice is that they are not necessarily the same for all observers. So observers can have different observables, different wave function, and different probabilities. Cubists refuse the idea that the quantum state of a system is an objective property of the system that is just related to the agent. So the quantum state in this version of the cubism is only a tool for assigning a subjective probability to the agent's future experience. It only represents the degree of belief of the agent about the possible outcomes of future measurement that the agent will do. So quantum mechanics does not directly say something about the external world. This is something that describes only the agent's experience. And a measurement in this interpretation is just a special case of what QBism calls experience, and this is what I described just before. That is any action taken by any agent on our external world. So we have to really understand that this is something that is for a single agent. Of course, any agent can use it. But when you use it, you have to use it as a single and unique agent. You don't share that with others. And that when you're doing actions on the, in quote, external world, which don't really mention, you have an experience, and a measurement is just the result that you get when you make such an experience. The result of the measurement is the experience the agent gets from her action on her personal world. And in this sense, for cubists, measurements are made continuously by every agent, because every agent is living in a world and is continuously experiencing something. And a measurement does not reveal a pre-existing state of affairs, that's not just witnessing something that is there, but creates a result for the agent. The goal of quantum formalism, then, is only to give recipes to allow the agents to compute their personal degree of belief about what will happen if they do such and such experiments. In this sense, that is very close to instrumentalism, even if they are reluctant to accept that. And when you say to a cubist that he is an instrumentalist, he just pushes you in the stairs because he doesn't like that at all. But that's a little bit like that. Cubists endorse a special kind of realism after Wheeler. That the term comes from Wheeler, and Wheeler is a big source of inspiration for cubism, that they call participatory realism, where the agent and the external world interact in a creative way to give birth to an experience for the agent. So how do they solve the measurement problem? As you know, the measurement problem comes from the conflict between two postulates of evolution. The first one is the unitary evolution coming with the Schrödinger equation that you have to use when no measurement is made on the system. And the reduction postulate, or the collapse of the wave function, you have to use it when you do a measurement on the system. The big problem in quantum mechanics is that it's not possible to define rigorously what a measurement is. And the measurement problem comes from that. That would not be a problem to have two postulates if the case when you have to use the first one and the cases when you have to use the second one were clear. But that's not the case, because what is a measurement is not clear at all in the usual quantum formalism. For cubists, this problem is solved in an easy way, because the unitary evolution of the wave function, which I recall that, is only the degree of belief allowed to compute the degree of belief of the agent. And the Schrödinger equation gives the way the degree of belief of the agent evolves in time. So the unitary evolution concerns the change between the belief the agent has at time t0 for the outcomes of a measurement she could perform at t0, and the belief she has at time t1 about a measurement she would perform at t1 superior to t0. That's clear. And as the measurement is the experience of an agent, when an agent has the experience of a result, then he knows a result, and the collapse of the state is just the updating of the agent's belief after she's got the result. So that's perfectly coherent. Modulo something that I'm going to say about the way the result appears. But that seems coherent, and that's the correct way to solve the measurement problem. Another point that is important to notice is that for cubists, quantum mechanics is universal. It is a universal theory, and you can use it to model everything except the observer, the agent himself. So the other agents are also modeled by the quantum formalism. And when you speak to somebody, you can consider this somebody as a measurement apparatus that's the same. It can be, he or she can be in a superposition. So agents have no particular status except for the agent himself that is using the formalism. A word about also the fact that they pretend to solve the EPR situation and the problem of non-locality. There is no non-locality in QBism. And the reason why is that, as I said before, everything is related to one unique agent. And quantum mechanics cannot assign correlations, spooky or otherwise, to space-like separated events, since they cannot be experienced by any single agent. Quantum mechanics is not explicitly local in the cubist interpretation. That's a quotation of Fuchs, Mermin and Schack, still in 2014. And the reason why is that they don't accept the agent to speak about a result that could be obtained elsewhere by any other agent, because that has no meaning for them. So they just witness the correlation when one agent, having made a measurement here, is able to ask for a result elsewhere. But of course, between these two events are mandatorily time-like separated and not space-like separated, so there is no spooky action at a distance. There would be, of course, many different things to say, but I have no time, and I just switch to some criticism that is possible to address to QBism. QBism leaves open some important questions, and it will be necessary to answer to this question to have a clear picture. I don't say at that step that there is something incoherent in QBism. I just address the criticism that many things are very fuzzy and are not easy to make clear. The first question is, what is an agent? And that's a question they don't like at all, because they say we don't have to say what is an agent. And they use the classical example of classical probability theory. And they argue that in classical probability theory, you can make plenty of theory without having to say what is people using the theory. Okay, and that's true in classical probability theory, mainly because what happens totally independently of the person who is going to compute probabilities. That's happening by itself in the external world. That's not at all the case in QBism, because the agent is creating the result. So, contrary to what they say, the agent is not at all an external concept in their interpretation. That's an internal concept that it should be able to describe, and they don't want to do that. So I had many discussions with Chris Fuchs in particular, and with Rudiger Schack and David Mermin about that. They don't agree between them exactly, that's not clear. Rudiger Schack once wrote me that a computer could be an agent, which I find totally strange, because at the time, I know that with ChatGPT now, questions are coming, but I don't accept that a computer could be conscious or having an experience, at least now. And so that's strange. David Mermin said, okay, I admit that for having an experience, which is needed in QBism, we have to have perceptions. That doesn't mean to be conscious, and that's very fuzzy. But this is something that they don't want to precise, and they left fuzzy the concept of agent. The second point is, what is the ontology in QBism? And that's not clear. Many possibilities are open. They seem to endorse the existence of an external world that is independent of any agent. But it's not clear for them if this external world is unique and shared by all the agents, or if each agent has her own external world. That's not clear. They say that the micro level of this external world is something unspeakable, and that there is no law ruling the behavior of micro-objects. Okay, but in 2006, Fuchs wrote, something new really does come into the world when two bits of it, system and apparatus, are united. So at that time, it seems that Fuchs thought that the result was coming from the interaction between an apparatus and the system. And now they have changed their point of view. This is not something that they say again. Because today they have abandoned this view. And the new version is a result comes from the interaction between an agent and the external world. And the result is only for the agent himself. Okay, but what does that mean? Is the result in the agent's mind or is it in the external world? That's not clear. If it's in the agent mind, then the result is non-physical. That's okay. But then it's not true that something new comes into the world, as they say. If the result is in the external world, how is it possible that the agent creates this result? They have no explanation of that. They don't want to talk about that. And all those things remain very fuzzy and would need to be clarified, which is not done yet. I switched now to Convivial Solipsism, and I started developing this interpretation after an initial remark from Bernard Espagna in his book Conceptual Foundations of Quantum Mechanics in 1971. And he repeated again that in Veiled Reality in 1994. And Bernard Espagna was not at all satisfied by the many-word interpretation. Mainly because he was not satisfied with the huge proliferations of words, which is he found totally strange. So he wanted to avoid that. And I'm going to explain what that means. I developed that starting from 2000 and then in a series of papers till now. Let me just start from the usual entangled wave function. We have a system S, an apparatus A, the environment E, and an observer O. And then, as we all know, we start from a superposition of the system, and then after evolution by Schrödinger equation, we have an entanglement between the system, the apparatus, the environment, and the observer. Okay. And in the Everett interpretation, the reason why we see one result is that each component of this wave function gives rise to one word and one observer. What happened in the Everett interpretation is that there is a multiplication, as you know, and observers. And what he wanted to do is trying to explain why we get one result, but with only one universe, one observer, without any multiplication. So how is it possible to get only one result from this entangled wave function when we have only one observer, one result? And the idea is very simple. Our brain is not able to perceive directly superposed state. We have limitation of brain, we all know that. Of course, we don't know exactly how our brain is working, but we know that we have limitations. And when we look at a superposed state, then we perceive only one component of the superposition. I'm amused to quote here Leif Vedman, because Leif Vedman said, Leif Vedman is a real supporter of Everett interpretation. And he said the reason we do not experience superpositions is not because they do not exist, but because we are not capable of experiencing several different states simultaneously. And I totally agree with him, but I draw the direct opposite conclusion from him, because from that he deduces that many-word interpretation is a good one, and I say that there is no need to have many words and many observers. And for that, I just show you, that's a spinning dancer, okay? And I have no time because the time is running and we have a very short time. But usually when I present that, I ask the people in the room, which sense do you see the dancer spinning? And usually half of the people say clockwise movement, and the others say counterclockwise movement. Okay, I suppose that's the same. And with a little bit of habit, it's possible even to reverse, but it's not easy, to reverse the sense you see the spinning dancer. Okay. Why am I showing that? Just because that's a funny illustration of something. If you ask what is the real direction for this dancer to spin, there is no answer, because she is spinning both clockwise and counterclockwise. That's a superposition. But we are not able to see this dancer spinning clockwise and counterclockwise simultaneously, so our brain just select one direction, and half of the people, half of the room will see them clockwise, and the other half will see them counterclockwise. Okay, that's just a funny illustration. But what does that mean? That means that when we have a superposition, and of course that's a quantum superposition, but when you have a superposition, our brain select only one possibility among the superposed possibility. And that's exactly what is the mechanism that is used in convivial solipsism. The universe and the observer remain physically in a superposed state. But the perception, the awareness that we have as observer of the superposed states is selected for only one component, and this selection is made according to the Born rule. That's of course a postulate, but that solves also the problem of probabilities that is pregnant in the multiple Everett interpretation. We know that there are many attempts to try to solve, to rescue probabilities in Everett interpretation, but that's not easy. And here there is no problem of probabilities, because I explicitly postulate the Born rule for selecting the component that is seen by the perception of the observer. So a measurement in this interpretation is nothing else than the fact that when we look at a superposed state, our brain selects one component of the superposition, written in the preferred basis, that's a detail, and our awareness hangs on to this component, and we are stuck at these components. Nothing physical happens. I will explain what that means in terms of the ontology, what that means for what is the reality in this case, and I will just explain that. So we have two main principles: the hanging-on mechanism, which is what I described, the way when an observer has a look at a superposition, it just can witness one component of the superposition. And the second point is that the same with QBism, or even the relational interpretation of Carlo Rovelli, the relativity of states, of observables, of wave functions, and so on. And that's exactly the same then for QBism and relational interpretation. That's just in details the proof that when two observers exchanges, then they have to agree on what they have seen, even if that doesn't has to be interpreted as the fact that in reality they have seen the same thing. What is the ontology? We have two levels of reality. The first one is what I call the empirical reality. And when I discussed with Bernard Espagna, this is what he called in his books the veiled reality. It's very similar. And the empirical reality is all the potentialities that the observer could actualize by having an observation, by having what we call a measurement inside this context. And it's described by the global entangled wave function. In the Everett interpretation, that's the universal wave function. Okay, that covers everything. And that's the empirical reality to which we have no direct access. We can't witness the empirical reality such as it is. Okay? And that's the reason why, even if I have called my interpretation Convivial Solipsism, in fact, that's a realist interpretation, even if the reality in my conception is very different from the usual reality. That's not idealist at all. That's not solipsist at all. That's just a provocation. That's the reason why, 20 years ago, I called that solipsism. But that's not a solipsism in the real sense of the term. And that's convivial because there is no possibility to disagree between observers. They always agree. And the empirical reality is the reality that is outside and that is described that is entangled wave function. Okay. And from the empirical reality, we built, each observer builds is phenomenal reality, which is the gathering of all the observation we make, and that is what we call usually our reality. Our usual reality is or what we witness or what we see or what we are sure of. And that's coming from the observation we make on the empirical reality, which is a little bit far from us. And there's two levels are articulated in a way that allows to describe our phenomenal reality, which is the reality that we are used to consider, as a sub-branch of a tree of sub-branches of the global entangled wave function. And this phenomenal reality, so the reality you are used to, is relative to each observer. That is, that we have no way to compare in reality from the God point of view, for a meta-observer point of view, which doesn't exist. It's impossible to state something like, Alice saw that, and Bob saw this, and they don't saw the same thing. That's a sentence that is forbidden in this formalism, because you have to express any sentence from the point of view of only one person. So you can't speak of the direct perception of anybody else. And this phenomenal reality is your reality, and it's relative to each observer. So quantum mechanics is about the interaction of an agent in QBism, an observer in convivial solipsism, and an external world that is far and not knowable directly. And the quantum state and all the formalism are relative to the observer. The collapse is not a physical event on the system, and the quantum formalism is universal. You can model any agent or observer with the quantum formalism, and the reality is relative to each observer. That's the common points. Now the difference, and I like to state that under what is clear in convivial solipsism and not in QBism, and I always discussed with Chris Fuchs saying that if you want to accept that QBism and convivial solipsism will converge, what a measurement is and why the observer gets one result is clear in convivial solipsism, even if I don't know, of course, to explain why our brain is working like that. But the reason is clear. And the status of reality that I've just described is not clear at all in QBism. That's the point that I mentioned just before, and I see that I have just 1 minute more. Okay, I stop. Thank you.